All right, we're back. We're still on page 8 of Notes 24. We're solving some differential equations, thinking about a lot of things, which is basically what happens when you get to this point, because this is kind of the end of the road for Calc AB in particular. So you kind of know how to do everything, so everything could come up. And that's the weird part about calculus. Like from day one till the last day, everything you learn, you just have to remember, which is a lot. And we know that we're asking a lot of you, but you kind of took on a lot when you decided to take this. So let's see if we can do it. Consider the differential equation, dy dx equals, this is quite the differential equation. The quantity y plus 2 squared, sine of pi x. All right, so find a value of c such that the horizontal line y equals c. I feel like this should be italicized. Such that the horizontal line y equals c satisfies, I don't know what I'm saying. Find a value of c such that the horizontal line y equals c that satisfies this, what? Find? I don't know, satisfies. There we go. Find a value of c, this is like wasting your time. Find a value of c such that the horizontal line y equals c satisfies the differential equation. Yes, there we go. That's a good sentence, I think. All right, so what do we know about horizontal lines? So, if y equals c, then what does dy dx equal? That's an arrow, by the way. Just didn't work out. And dy dx would have to be 0. All right, what value of y is going to make dy dx equal 0? Therefore, I'm going to say y equals -2. Because if y equals -2, I mean, look at your differential equation. If y equals -2, then dy dx equals 0 times sine of pi x. Now, there are values of x that will make the derivative equal 0. That doesn't really matter. That's not the question here. The question is, what horizontal line, so y equals c, makes it equal 0. So I'm going to say, therefore, c equals -2. I use therefore too much, I think. But anyway, this is your thought process, or my thought process. I'm looking for the slope equals 0. I can see that either y is equal to -2 or sine of pi x equals 0. I don't want to solve that. Well, I mean, that's like 0, 1, 2. It's all the integers, actually. But specifically, we wanted y to equal -2. All right, and then find the particular solution, y equals f of x, to the differential equation with the initial condition, f of -1/2. That's gross. Oh, because the sine of pi x, I guess, equals -3. All right, let's do it. So I think I should write the differential equation. So dy dx equals, this is the first step. First step of, it's like trig identities. The first step is to write the problem correctly. If you don't write it correctly, like it doesn't matter what you do. All right, we got this. So I'm going to separate dy over y plus 2 squared is sine of pi x, and then you pick up a dx. All right, now integrate. I don't really like the way the left-hand side looks. I would prefer to have y plus 2 to the -2nd. So I'm going to actually do that. This is, you got to make those decisions for yourself. Like if you're comfortable, just go for it. And like, you know, when I'm doing problems by myself, I am comfortable with that. But like when I'm trying to explain them to people, I just know that at some point I'm going to have to go back and do it anyway. So like, why not do it to begin with? All right, +1 times the reciprocal gives us negative, and I'm going to rewrite this as this, equals, all right, the integral of sine of pi x. So it's going to be negative because sine goes to negative cosine. There should have been a pi in there, so I'm going to put a 1 over pi, and then cosine of pi x, and then you get your plus c. Is there ever going to be a better time to solve for c? I don't really think so. So I'm going to just go for it now. All right, so we're using our initial condition. I like when it's one solid color. I don't know. I don't know if it was in a calc video I discovered this. It's like when you pick it up, it does like this weird thing. But if you don't pick it up, you can kind of like paint the whole thing. And I like that. All right, so initial condition, plug in -3, you get -1 over -1. So just 1 is equal to -1 over pi cosine of -pi over 2 plus c. Cosine of pi over 2 is 0. Cosine of -pi over 2 is 0. Cosine of pi over 2 plus pi n, where n is an element of the integers, is 0. So this is just going to tell me that c is equal to 1. Okay, so I have negative 1 over y plus 2 is equal to, I'm going to write it as 1 minus 1 over pi cosine of pi x. I'm doing that just because I think it looks better. You could do the negative thing and then plus 1. Doesn't make a difference. I'm partial to that, I guess. And then where are we going from here? So I am going to, it looks so weirdly pixelated. I guess that's because it zoomed in. I don't know. Anyway, all right, I'm gonna multiply through by a negative and then switch them again after my whole thing there. So again, I like to show a lot of steps on these because I make a lot of mistakes on them. And it's easier to find the mistake if you showed a lot of work. So I am, however, going to skip here. I'm going to say that because of this, y is equal to, so it's really y plus 2 is equal to, I'm just going to subtract 2 from both sides. And then I'm going to flip this over, take the reciprocal, technical term. I'm not one of those people who worries all that much about those kinds of technical terms. I think we get that. All right, I'm feeling good about that. So this would be f of x. It always says find y equals f of x. So like, did I do it? I found y. I didn't say it was f of x, but y equals f of x. So if I found y, I guess I found f of x. I'm gonna paint this. Okay, so I think that's my solution. You know, so maybe there's like a domain issue you'd have to worry about. Not really, because 1 over pi is like really small. Well, not really small, but basically the denominator there is never going to be equal to 0. Like it can't be. So I don't think we need to worry about that. I'm going to use the calculator to solve this. Hopefully it works. I mean, it's going to work. Hopefully everybody can see it when I do it. So new share. All right, we're on the calculator. And I'm going to do DE solve. So that's menu 4, and then press up a couple times, and you'll get like a wizard, but it's just as easy to like memorize what to do. Well, it's not. It's easier to use the wizard, but I already have this memorized. So, you know, back in my day, we didn't have wizards for everything. Also, I really like the way it's called a wizard, like, you know, like from like Lord of the Rings, Harry Potter, XY. It's like a little wizard appears and helps you. What do you mean argument error? And oh, f of, come on now. And y of -1/2 is negative. All right, so what have you done? What is this? Is that somehow, oh, you know what it did? Can I expand that? It got a common denominator. Oh, wow. It got a common denominator. And also then it like simplified the pi. This is equivalent to what we got. So I didn't know what was happening here. And then I realized like, oh, it combined that like -2. So I used expand, which is in menu 3, if you want to find it, menu 3. Expanded it, and now I can see that it's equivalent. It did do a little bit of common denominator in the denominator type thing, but it worked out. So we got it. So I'm going to go back to the notes, hopefully, and you can take another look if you want, but we got it. So I'm going to cut this video here, and obviously I will be back in the next video to do even more stuff. So I will see you there, hopefully. So, you know, hope you're finding these helpful.